Guys, welcome back to TechDose, and in this video we will look at maximum difference between even and odd frequency 2 problem, which is from Leetcode number 3445. In this case, if you have already solved range sum query mutable, then you will know about how to find the range sum query. If you haven't solved it, then you can find the link in the description below, and you can also consider solving this after having solved this current problem. Now in this case, you are given a string s and an integer k. Your task is to find the maximum difference between the frequency of two characters, frequency of a minus frequency of b, in a substring subs of s, such that subs has a size of at least k. The character a has an odd frequency in subs, character b has an even frequency in subs, and we need to return the maximum difference between the frequency of a minus frequency of b. And we should note that subs can contain more than two distinct characters. So in this case, once you know that you are given a certain size of, let's say, a string or an array. String is an array of characters, right? If you are given a certain size of array, and if you are talking about maintaining certain condition in such a way that the subarray size must be at least k, that means the size must be greater than equals to k, then you should note that you are asked about maintaining a window, or you can say that a subarray, in such a way that you can actually make this window elastic. You can increase the size, you can decrease the size, but the decreased size must never go below k. So this is the case of variable size window, variable window size, because it is saying about at least k. So the window size can be k, k plus 1, and so on till n, right, where you can have the entire array as one of the windows. So it is not just saying about one window size, but the minimum window size is k. So that means it is saying about a variable window, and if you want to parse through a window from one end to the other end of variable size, then you know that you have to maintain two pointers l and r, where if you make r go to the right hand side, then you are increasing the size of the window, whereas if you make the L go to the right hand side, then you are decreasing the size of the window, right? So you can maintain variable size window by using the two pointer technique, two pointer plus sliding window. Okay, so when you do sliding window, then you can have two types. You can have variable size, or you can have fixed size sliding window. In the variable size sliding window, you have to use two pointer to maintain the boundaries of the window, right? So as soon as it says about substring subs of the string s, which is having at least size k, your mind should think about a variable size sliding window using two pointer, right? So this is pretty obvious. Now whenever you have picked a window, within that there will be a certain frequency of a and certain frequency of b, and whatever is the difference, you have to maximize this difference. You have to maximize this difference. Okay, now if you consider the values of a and b, let's look at the constraint first. So if you look at the values of a and b, you have exactly 5 digits into consideration. So you have digit 0, 1, 2, 3, 4. Okay, so if you create pairings of a comma b, then you can take a to be 0, and then b can be taken from 1 to 4. You can take a to be 1, and then b can be taken as 0 or 2 or 3 or 4, because you will not take the same numbers, right? It is not taken as the same number. A and b are different. So for 0, you can pair it up with 4 possible numbers, 1, 2, 3, 4. And similarly for 1, you can pair it up with 4 possible numbers, which is 0, 2, 3, 4, and so on. The same will go for 2, 3, 4. So each of the digit can be paired with 4 options, and therefore since there are 5 digits, you will have 20 pairs possible. 20 pairs possible, right? Now if you know the standard sliding window, then a standard sliding window is order of an approach to actually parse the entire array from one end to the other end. So if you have already pre-assumed a to be, let's say, 0 and b to be, let's say, 1, then you have created one pairing, and for this pairing, if you want to find out the window where you have the maximized value of f of a minus f of b according to the problem statement, then it will take order of n time. So you can try for all possible combination of pairs, not just for 0, 1, but also for 0, 2, 0, 3, 0, 4, 1, 0, 1, 2, and so on. That means all the 20 pairs and for each of them it will take order of n time. So the total runtime in this case is going to be 20 times of order of n, and the order of n here is 3 times of 10 to the power of 4. So if you multiply these two, it will be 6 times of 10 to the power of 5, which is way below your 10 to the power of 8. So this is going to run well within your 1 second if you try to follow the optimal sliding window using the two pointer approach and trying out with all possible pairings according to the input constraints, right? So we will be trying to do that. The input is generated such that at least one substring has a character with an even frequency and a character with an odd frequency. So if you try to take all possible combinations, then at least you will find f of a to have odd frequency and f of b to have even frequency, so that at least an answer is possible. Okay, there will be no input where answer will not be possible. Now in this case the k value is ranging from 1 to s dot length. That means the window size will always be within the size of the entire string. Now if you look at the example given, then in this case in the first example you have 1 2 2 3 3 and the k value is 4. That means the window size must be 4. So if you look at the indices 0 1 2 3 4, now if I take a to be 1 and b to be 2, then what is f of a? That means the frequency of a. You have to also select a window, right? Let's select a window from 0 to 3. Let's select a window from 0 to 3. So here the frequency of a is 1. That means a was considered 1. So 1's frequency is 1. F of b, that means the frequency of 2 is also 2 here. So this frequency must be odd, and yes, it is correct. This frequency must be even, and yes, this is correct. So what is the value of f of a minus f of b that you get for this particular window size for the assumed pair of 1 comma 2? In this case you get 1 minus 2, which is minus 1. Okay, now if you take any other window, you cannot take a window size of less than 4. If you take any other window, like let's take a window from 1 to 4, and for this a and b value being 1 and 2, find out the frequency of a. It is going to be 0, and frequency of b, which is going to be 2. So this is even and this is fine, but this is not odd. This is not odd, it is 0. So this means this is an invalid window, isn't it? So accordingly you can keep checking for all the pairings, all the 20 pairings, right? And you will find that minus 1 is the maximum value that you could get, and that is why minus 1 is the answer. Again, you can look at the other examples as well. In the second example you have 1 1 2 2 2 1 1 with the k value being 3. So in this case the answer is 1. And how did you get 1? If you take the a value to be 2 and the b value to be 1, then in this case if you select this window 0 1 2 3 4 5 6, so if you select the window from 0 to 4, is it a valid window size? Yes, this window size is 5, which is greater than equals to 3. So this is a valid size wise it is correct. Let's see count wise. So the frequency of a, where a is 2, is equals to 3, and it should be odd, and yes, this is correct. The frequency of b, which is assumed to be 1, in this window the frequency of 1 is 2, which must be even, and yes, this is correct. So that means the frequency of a and b being odd and even, it is correct. The size was also greater than equals to k, so this is a valid window. Now in this case you can calculate f of a minus f of b, which is 3 minus 2, it is 1. Okay, now we got 1 in this window, and if you calculate across all the window sizes, all the valid windows, then you will not get any value greater than 1, and that is why 1 is the answer, right? So I think you have got the idea of this entire problem. So once you have understood that we are going to solve by sliding window two pointer approach, then let's see how to apply the sliding window. Now I have taken an example with 12 elements, and here k value will be 3. So for the odd even combo I am taking a to be 2 and b to be 1. So I will find the frequency of 2 and frequency of 1. Frequency of 2 must be odd and the frequency of 1 must be even. Our goal is to maximize f of a minus f of b, that we already know from the problem statement. And if we apply the sliding window 2 pointer, then the right pointer will start at index 0, left pointer starts at index 0. In general sliding window approach, we move the right pointer to the right hand side, and we have to define a stopping condition, right? and when right pointer stops, then the left pointer moves from left to right hand side, and we have to define a stopping condition for that too. So the general sliding window rules will be defined for when to stop the right pointer when we move from left to right, and the second point is when to stop the left pointer when the left pointer moves from left to right. So for the first case, for stopping the right pointer, we can take a very simple scenario where I say that if the window size is k, then I will stop. Okay, size wise, if the window is valid, then I will stop. That means when I start moving at this point, then if r goes to this index 2, then I will stop, because this is a size 3 and this is valid. This is valid size. Okay, because the size must be greater than equals to 3, we will stop. We are trying to keep it simple for the time being. Now when should the left be stopping? Let's say that we will just move the left one time to the right hand side in such a way that the 0th element will be lost in this case, and if this element is lost, then we have to decrease its frequency. Now the 0th element is 0 here. If it matches with any of the a or b, the frequency of a or b will get decremented. But if it do not match with any of the a or b according to what combination we have taken, then it will not be affecting the frequency, and you can simply move the left pointer to the right hand side. So you need to keep a track of whichever element you are losing, is it affecting the frequency, then you update the frequency, right? So I think this simple approach is clear. But the problem in this simple approach is you are not maintaining variable window size, but you are only maintaining the k window size. So when r stops as soon as you reach to r minus l plus 1 greater than equals to k, then the window size is exactly k. Okay, and then the l pointer moves to the right, then in the next iteration the r will stop at 3. Then the next time l will move to 2 and r will move to 4, and so on. So in this case we are not covering all the cases. We are covering the cases where the window size is exactly k but not greater than k. Okay, so this will give you correct answer only for certain scenarios where the answer is contained in a k size window, but if the answer is contained in a window size greater than k, then it will give you wrong answer, isn't it? So our problem here is that we are not able to check for a higher window size than k because of the simple rules. So we need to do certain kind of modification or the rule, or otherwise we need to apply the 2 pointer in a different way. So let's see how to apply it. Let's say that my right pointer is present at certain point, and I am assuming it to be present at, let's say, point 10. Now our assumed combo in this case is a to be 2, where frequency of a must be odd to make a window valid. B is 1, that means frequency of 1 must be even to make a window valid, and the size wise the window size must be greater than equals to 3. Okay, once we have known this, then if the right pointer is at 10, then where will you place the left pointer? Now since you know that the window size can be greater than equals to k, therefore at least it should be k, so the left pointer can be placed either at 8 or at any index ranging from 0 to 8, isn't it? Any index ranging from 0 to 8. It cannot just be 8, it can be any index. So now which index will you choose? It is up to us to choose whatever index we want. So we will choose a certain index in such a way that, let's say I tell you that let's choose this index. Then this index will only be chosen if in the middle the count of the frequency of A is odd, first of all, then the count of frequency of B is even, and in such a way that f of A minus f of B is maximized. It is maximized. If all these conditions are followed, along with the size being greater than equals to k, if all these conditions are followed, that will be the optimal position of L. That will be the optimal position of L. Okay, so since I know that f of A minus f of B have to be maximized, f of A minus f of B have to be maximized. So if this entirely has to be maximized, then you can also look at the separate components and say that if f of A can be increased, then this will be maximized, or if f of B can be decreased, then this will be maximized, or if both of them can be parallelly increased and decreased, then it will be maximized, right? So you can break down the goal saying that I will minimize f of b or I will maximize f of a. So I have to place the left pointer according to where this optimal point is hit, because L is just one pointer, right? We do not have two pointer, it is just a one pointer. So I have to check a balance between B and A frequency. Okay, so where to place it? Now let's say that I chose to place this L here. Then how to find like what is the frequency of A and B in the middle? So what I will do is, if you had placed L here, then I can iterate and find the frequency of 2, and that is equals to 5. Yes, it is odd. And I will iterate and find the frequency of 1, it is 2, and yes, it is even, and I can find the difference between them. 5 minus 2, it is 3. So the value that you get here is 3. If you try across all windows, then you have to try to maximize this value, this type of value, right? Now how much time did it take? If I selected this 0.3, then it will take order of n time. That means all the items could have been in the middle, right? So it will take order of n time to calculate what is the value of f of a minus f of b. So that has to be tried for all the indices from 0 to 8, isn't it? That has to be tried, repeated for all the indices. But instead of repeating it, what we are maintaining is count in a range. So if you think about, if L was present at 3, what I was interested in, count of 2 in the range of 3 to 10. If you think of count of range 2 in the range of 3 to 10, how to get it more optimally, then you should think about the prefix sum. You should think about prefix sum maintaining the count of 2 at any particular index, isn't it? At any particular index. So if I apply the prefix sum for the count of 2, I can say that count of 2 is 0 here, 0, 0, first time, so first count, 2 count, 3 count, 3 count, 3 count, 4 count, 4 count, 5 count, and you can say here it will be 5. And similarly, if I can maintain the prefix count for, this is for A, if I can maintain prefix count for B, which is 1. So here 0 count, 1 count, 2 count, 2, 2, 2, 3 count, 3, 3, 4 count, 4, this is 5 count, isn't it? So if I can maintain here, and if I have to now check how many items are in the middle, like let's say I said about placing L here, right? L at this point, then you want to check like how many count of items A and B are present in the middle. So you know that R is present at this 10 at this point and L is present at this point. Then you can easily calculate it. You can get the f of A minus f of B by simply subtracting this value difference with this value difference. Why is this happening? Because 5 minus 4 equals to 1 is giving you f of A minus f of B in the range of 0 to 10. In the range of 0 to 10. Okay. And if you think about what is 1 minus 2 giving you, 1 minus 2 equals to minus 1 is giving you the f of A minus f of B in the range of 0 to 3, isn't it? So if you subtract these values, like if you subtract 1 with minus 1, it becomes 2. This means that you are getting the result in the range of 4 to 10. But what I'm interested in is getting from 3 to 10, not from 4 to 10. So that is why I will be subtracting f of A, f of B in the range of not 0 to 3 but 0 to 2. So that means I have to look at the previous value. So this value, right, not 1 comma 2 but 0 comma 2. So if you subtract 0 with 2, then this will be minus 2. If you subtract 5 from 4, it will be 1. So if you subtract 1 with minus 2, then this is going to be 3. That means the f of A minus f of B value is going to be 3 in the range of 3 to 10. It is just the same concept as the prefix sum range sum query, and that is why I asked you to solve that problem, range sum query immutable, which is simply solved by using the prefix sum technique, right? So I think you have figured out that we will be using the prefix sum in this case along with the sliding window 2 pointer technique. Okay, so I have taken the same example and I have created prefix sum a of size n plus 1, where n is the number of items, which is the string size in the beginning, and prefix sum b, which is of the same size. I had also assumed a to be 2 and b to be 1. Okay, now in this case, if you see, prefix sum a size is 1 extra, because you know that if you want to find range sum in the range of L to R, then you can also take just prefix sum at R minus prefix sum at L minus 1, and you don't have to worry about the case for the boundary condition where L minus 1 goes to an index less than 0. Okay, in order to compensate for that, I will be appending one extra item on the left hand side. Okay, so this is just a dummy item. It will always start from 0. Fine. So this is how I have created prefix sum a, prefix sum b. Now in this case, in the previous example, I had showed that R was already present at index 10. So if you make R go to index 10, then where will L go? You know that k value is equals to 3. So L can go anywhere in the range of 0 to 8. L can go anywhere. So again, we may have to try out all the indices, isn't it? So we may have to have L here, that means at index number 0, and try to find out the value of f of a minus f of b, which is done by taking at 10 what is the difference between this 5 minus 4, which is 1, and take this 1 and subtract it with the L minus 1th value, that means 0 minus 0, which is 0. That means the difference between the count of 2s and 1s will be 1. You check it out. 1, 2, 3, 4, 5 2s and 1, 2, 3, 4 1s, right? So this is how it is done. Now, if you check out, okay, this is how you can calculate it, f of a minus f of b, and you have to parse this L for the entire range from 0 to R minus k plus 1. But if you think about the validity check, how do you maintain that it is a valid window? You have to also check for that, isn't it? So if you are present at any particular index, like let's say you are present at this index L, then in this range from 4 to 10, the count of 2s may not be odd. It must be odd in order for the validity to happen. Okay, whatever a you have assumed, you cannot have even count of it in the window. So 4 to 10 is not a valid window. So no need to calculate the subtraction value, isn't it? So that we need to take care of. I will show you how to take care of that. But before this, for any particular R index, since your L is moving from 0 to R minus k plus 1, for every R point you are taking order of n time. So for all the n number of R points, your algorithm is going to run in n square time. Even after taking the prefix sum, we have not improved our solution. Okay, n square is not going to solve our problem. We have to solve it in order of n. Now, how to select the optimal L value in just one step, having to do two things. The first thing is the validity. That means whatever L value I point to, it must be valid in terms of size, and valid in terms of f of a being odd count and f of b being even count. These three things have to be taken care whenever I point L somewhere. And also the second thing should be, it should be optimal. That means wherever I make L point to in the range of L to R, that f of a minus f of b must be maximized for all start points ending at R. Okay, for all the starts points and ending with R. So if I say that L will point to 4 and this will give me the optimal result when R is at 10, then this must be giving the maximum value of f of a minus f of b when I try out L for all the options from 0 to 8. Okay, this should be giving you the maximum one. So that is why these two conditions have to be taken care, and I have to take care of these conditions in O1 time. Only if you take care of this in O1 time, you can make an optimal choice for every R index in order of 1 time, and hence your algorithm will change to an order of n sliding window algorithm, right? So first let's see like how to choose how to take care of odd even, because you already know how to take care of size, isn't it? If r is the index, then you can go from 0 to r minus k plus 1. This is how you take care of size. Let's see how to take care of the odd even index. Now for that to happen, let's say that your r pointer is at 10. So my range is going to be from 0 to 8. Now if you look at this index 10, then what is the meaning of this 5? The meaning of this 5 is my a was 2 and my b was actually 1. So the meaning of this 5 is the frequency of a is actually 5 right from the beginning. From beginning means from index 0. The frequency of a is 5. The 4 here means that the frequency of b is equals to 4. So what is this? A must be odd and b must be even. Okay, initially they can be anything, right? They can be anything. They could be odd or even, it does not matter. So in this case it is 5 which is odd and frequency of b is even. Now where I should place this L? So I should place this L in such a way that the count of a, that means the frequency of a in this range from L to R, must come out to be odd, and the count of b in this range of L to R must come out to be even. So if let's say in this particular scenario, if let's say that the count of a was 5 which was already odd, and you want to subtract it with some another count of a, let's say f a dash. Okay, so f a is let's say from the beginning it is till the end, and f a dash is from the beginning till L minus 1 index. So if you want to subtract them, this is an odd count. Okay, the final in the middle is something that you are finding, you have to get it odd count. Then what should be the count of this f of a dash? It must be even, because odd minus even will only give you odd. If f of a dash is odd, then this is not going to work, isn't it? So based on that, I can tell you that if you know this rule, it will be very helpful. Otherwise you can just go through it. Even minus even is always even. Even minus odd is odd. Odd minus even is odd, and odd minus odd is even. If you know this rule, then according to that I have made the statement that if f of a dash is even, then only you can place this L at index 3. Otherwise you cannot. And for the same reason, f of b is 4 which is even. The final count of b must be even. So if you subtract even from even, you always get even. Otherwise if you subtract odd from it, then you get odd. So that means f of b dash, which is the frequency from the beginning till L minus 1, must be even. Otherwise this L index at 3 is not going to work out, right? So again I can generalize this entire thing, and I can say that if your right pointer is present at R, where f of a is the count of a from beginning, from 0 till this index R, which is x is the count, and f of b is y, that means the count of element b from index 0 to R is y, then I can just compare it with an L pointer where you want to place, so that from 0 to the previous value of L pointer, if you get f a dash to be p and f b dash to be q, then in between you have to get x minus p to be odd for sure, and y minus q to be even for sure, because the f of a in the middle must be odd, and the f of b in the middle must be even. This is according to the problem statement, isn't it? So if now I say that x is odd, then you can look at this chart, and simply you can say that if on the left side you have odd, then these two cases will hit, and if on the right side you have odd, then only this case is going to hit, right? So if this is odd and the third one is odd, the second value must be even. That means the p value must be even. If this is odd, then this will be even. Okay, and similarly if this is even, then this has to be odd. You see, even minus odd is odd. Similarly for this b, if this is even, this has to be even. If this is odd, then this has to be odd, because even minus even is even, odd minus odd is even. Even minus even is even, and odd minus odd is even, right? So according to that, there will be 4 states that we will have to manage. 4 states. So given a combo p comma q, in this case I have taken a comma b as the combo, right? So if you have taken p comma q as the combo, then for that, either this p is even and q is even, or p is even and q is odd, or p is odd and q is even, or p is odd and q is also odd. So there will be 4 states: even even, even odd, odd even, odd odd. If I can represent this using 2 bits in such a way that even I will represent by 0 and odd I will represent by 1, then even will be represented by 0 0 in binary, and that will be represented by a value 0 in decimal number system. Similarly, even odd will be represented by 0 1 in binary, which will be value 1. Odd even will be represented by 1 0 in binary, which will be represented by a value 2, and odd will be represented by 1 1 in binary, which will be represented by value 3, isn't it? So this is how I will be representing the 4 states, and that is why I have taken 0 1 2 3. Okay, I hope this is clear. Therefore, while solving the problem, we must consider what is the state of xy. If x is, let's say in this case, even and y is odd, then the state is going to be 0 1 in binary, that means 1. The state is 1. So what we are looking at as the target on the left hand side, if this is odd, then the left hand side as well you are looking at odd. If this is even, then you are looking at even, right? But if you look at A's frequency, it is flipping. So if you see here, if you have even, you are looking for odd on the left side, isn't it? And if this is odd, then you are looking for even on the left side. So the parity is flipping for A, whereas the parity remains the same for B. So that means if x is even and y is odd, I'm just considering an example, even odd, then what we are targeting on the left hand side for PQ's parity is E will be flipped, so this will become odd. Odd will not flip, it will remain as odd. So we are looking at OO, that means odd for P and Q as a parity. So this parity will actually take care of about the 4 cases that we had seen previously, right? So I was showing you about this odd even cases. The parity will take care of it. The size will be taken care of by us. And now it comes to the optimal check. So for the optimal check, you can say that if I have an R, then I will put an L, like I will choose an index L in such a way that whatever is the diff value here and whatever is the diff value at this point, if you just subtract them, then that should be maximized. Okay, because that will give me in between the value for f of A minus f of B according to the range sum query prefix sum technique, isn't it? That is what we are trying to apply. Now if you look at validity case, we have one more case. The case is whenever you select a sub array, then the frequency of A must be greater than 0 and frequency of B also must be greater than 0. That must be true. These two things must be true. So if you choose a sub array, like let's say you have chosen certain sub array, like if I can pick this one, okay, this one as your R, and if you pick this one as your L, then will this be valid? If you look at these two values are same, this means in between to the right hand side, in between there is no occurrence of B. There is no occurrence of B. So if there is no occurrence of B, then simply this is not a valid window, right? This is not a valid window. Now I will only be checking for B, I will not be checking for A, because on B side, if this is having even parity, I will be searching for even parity on the left, and even if you don't have any items in the middle, you will find the same parity. Okay, but on the A's case, it will not be true. If here you have an odd parity, you will be searching for an even parity. So the parity flip cannot happen without an element. Parity flip cannot happen without an element, because if I say that you are taking mod 2, and that will give you a value either 0 or 1, and here you have a value n. Then if n mod 2 was, let's say, 0 and you require 1 now, then n mod 2 will never give you 1. It cannot give you two different values with the same mod, isn't it? With the same n value. So it must be n plus 1 or n plus 3 or somewhat a different value than n. Otherwise it will not give you a different parity, right? I will not be checking for the equality, but for B I will check for the equality, because the parity is same, and same parity can occur even without occurrence of the numbers. Okay, but the last question which still remains is how we are going to optimize it. We have seen everything about validity, all the 4 points, but what about the optimality? So for optimality we will be taking two arrays. One will be the min value array. So min value array will be of 4 size, which will be covering all the cases even even odd, then odd even, and then odd odd. So this will be containing, when you are sweeping from one side to the other side, from left to right, when you are sweeping the L pointer, when it is sweeping, then what is the minimum value of fa dash minus fb dash that you have seen, where a dash and b dash, I am saying that a dash and b dash are the same as a and b. I'm just trying to differentiate them based on L being the endpoint or R being the endpoint, right? If R is the endpoint, I'm using a and b. If L is the endpoint, then I'm taking a dash and b dash, right? So it will contain the minimum value of fa dash minus fb dash in the range of 0 to n minus k plus 1, so that when you have to pick a optimal L for any value R on the left hand side, if you want to pick an optimal L, if the parity here is odd even, then you will be going to find even, right, on the left hand side. So even is 0. You can go to this 0 and look at the min value, and you can simply return the minimum value of fa dash minus fb dash, right? So this will be done in just order of one time. Now if you have not understood this, then I will be showing you in the dry run how to maintain that. Okay, so let's look at the dry run. In this case I am taking 12 items, and I will be doing this just for one combination 2, 1, where 2 is our a value, which must have odd frequency, and 1 is our b value, which must have even frequency, right? Now if you look, I have already pre-computed the prefix sum a, prefix sum b, and I have taken a min value of size 4 covering all the 4 states. So when we sweep from left to right, if my R value is here and my K value is, let's say, equals to 3, then it will contain all the minimum values in the range of n minus K plus 1. Okay, so n minus K plus 1 is 7, but I will be maintaining till L minus 1 index, right? So that is why I am pointing to 6 and not 7. So I hope it is clear what we are trying to do. So in this case I will be assuming the K value to be 3, K value equals to 3, right? And we will be doing our dry run. Now the minimum index will tell you wherever the minimum occurred, what is the index of it. Okay, why it is important? It is important so that you can match the B's frequency. If the B's cumulative count is same, then that means in the middle there is no count of B occurring, and that is how you can identify the invalid case. Okay, so I'll show you in the dry run how to do this. Now before starting, since I want to calculate the maximum difference of fa minus fb, f of a minus f of b, so that's why I am taking a max difference variable defined to minus infinity. Okay, and here the base case which I will be considering is min value at 0 will be 0, min index at 0 will be 0. Why is this? Because this is the condition when your L is pointing to 0 and R is pointing somewhere, and you are including everything. So if you are including everything, then you are not excluding anything, because this prefix sum is actually counting from left to right for the items that you are excluding on the left hand side, isn't it? So you are not excluding anything, so you will be having 0, or you can say you are not including anything. At 0 you don't have any value, right? So initially I will be starting with a min value of 0 for the even case, and it is occurring at index 0. That's what I will assume. So let's start at index 3. Now index 3 means that index 2 in the original array, right? Now if you see this index, the parity on the A sum and the B sum is even and even. Now if you find out the left side target, then the parity, as I explained, for this A will be flipping to odd, and the parity of the second one will remain to be same, which is odd even. If you go to odd even, it is saying infinity, which means that there is no valid left pointer. Okay, there is no valid left index which can be chosen in such a way that L to R will be maintaining the frequency of A to be odd, frequency of B to be even, the size is also K, and all those conditions are satisfied, right? It will not be satisfied. That means we cannot maintain the frequency of A and B to be odd and even. And that is true. You can check it out. It is true, right? If you check this array, the frequency of A, which is 2, is 0. That means A is not occurring. Both of them must occur, right? They are not occurring. So this is not valid. So we have to move to the right hand side. But before moving to the right hand side, we have to account for this one. This has to be saved in our min value, because now our L will be ranging with this 0, right? Once the R moves to the right hand side, then my range from 0 to n minus k plus 1 and to the left of it, so I will be subtracting one more, because if I want to get the items in the middle from L to R, then I have to take from 0 to L minus 1, right? So it is n minus k plus 1 minus 1. So now when R is sliding to the right, then this information has to be updated into the min value, because the min value will try to track case by case all the FA minus FB minimum values. So let's see, at this index 1, 0 means index 1 here, right? Because this 0 is dummy here. So this 1 is having even parity. Okay, so this is the case for even, and now the difference between them FA minus FB is 0. Okay, so at even it is already 0, so we are not able to minimize it, so let it be there. Okay, and now we are calculating for this 4. We are calculating for 4. At 4, what is the parity? Odd even. So odd even is the parity. So that means on the left side we want even. So if you look at even, do I have infinity or some integer value? Yes, we have an integer value. So it is occurring at index 0, right? It is occurring at index 0. So if you look at the count here at index 0, the count of B is 0, and at this particular point it is 2. That means B is occurring. We will not be checking for if A is occurring, because if the state is flipping, then that means it must have occurred in the middle, right? So that means we have a valid L on the left hand side, and that L will be at 0 only. So if we place our R here, then yes, we can place L at 0 in such a way that in the middle the frequency of 2 is going to be 1, which is odd, and the frequency of 1 is going to be 2, which is even, and so it is possible to place at 0, right? And that is what this is saying, that 0 is the optimal point where I should place. And how to get the value? So you already know FA minus FB from 0 to L minus 1, and that is going to be 0 here. And at this particular point 4, you can subtract 1 with 2. So that will be how much? 1 with 2 will give you minus 1. So if you take minus 1 and subtract from 0, it is going to be minus 1 only, right? So the difference is going to be minus 1. Now the max difference is minus infinity, so minus 1 is better answer, so update it. Okay, minus 1 is better answer, we have updated it. Fine. Now we have to move forward. Before moving forward, you have to save this into the min value. Let's see what is the state. It is even odd. So look at this even odd. Okay, and see the value. What the value is coming? 0 minus 1, which is minus 1. So minus 1 is actually a smaller value. We want to minimize the option for each of the state. So this is minus 1. At which index it is occurring? At index 2. So update this to index 2. Okay, and now we will be moving forward to index 5. 5 means 4 here. Okay, now at 5 you check the parity is even. So what parity I want on the left side? Odd even. So if you look at odd even, it is infinity. That means there is no option on the left hand side. If there is no option, then that means you cannot form a valid window if you have R here. So what we have to do, we have to move to the right hand side, but before moving we have to save this information because the range of options for L is increasing, right? So this option has to be saved. So this is 0 2, that means even state is even, right? So look at this even, and what is the value? 0 minus 2, so this is coming out to be minus 2. So let's update it. At which index it came? It came at 3, so update the index to be 3 and move forward. Even though you will see that sometimes I will not be comparing the frequency of B, but that has to be always compared. Okay, when we are at 6, the parity is odd even. So the parity here is odd even. So that means on the left hand side we want even. Okay, on the left hand side. So where is even occurring? Even. Okay, it is not infinity, so that means it is valid. Even is occurring at index 3. So let's look at index 3. This value is 2 here. Where we are present at 6, this value is also 2. That means B's frequency has not occurred in the middle. So this is not valid. Okay, this is not valid. So we need to move forward. Before moving forward, I have to save this into the min value. What is the parity? Odd even. Odd even is the parity. Look at odd even. This is infinity. So I can improve it by doing 1 minus 2, which is minus 1. And this is happening at index 4. So save index 4 here. And now I will be moving to index 7. Okay, index 7. So at index 7, if you see, this parity is odd. Parity is odd. And then I will be making a requirement for even odd parity on the left side. So let's look at even odd parity. This is present. This is not infinity. Okay. And this even odd parity is present at index 2. So go to this index 2 and check this value 1 and this value is 3. That means frequency of B is not 0 in the middle. It is greater than 0. So it is fine. So that means this is a valid option to be taken. This is the optimal option where you can place L, right? It is saying 2, that means you can place at 1. This is saying 7, so you can place R here at 6. So what will be the value FA minus FB in the middle? It is 3 minus 3, which is 0, minus whatever is the value here, which is basically 0 minus 1, right? So it is minus 1. So 0 minus minus 1 is going to be 1. Okay, 1. So I want to maximize the difference. So 1 is better than minus 1. So update it. Okay. So I think the things are getting clear for you. Now let's move forward. Before moving forward, I have to save this state. So this is even. So go to this even and check the value. 2 minus 2 is 0. Already I have a lower value, so don't update anything. Go to 8. Parity. Check the parity. Odd. So this parity is odd. What is the requirement on the left side? Even odd. Look at even odd. It is saying a non-infinite value. That means even odd parity is present and this is present at index 2. Check the frequency value here 1. Here the value is 3. That means B is present in the middle. Okay. Now you have to see the values. The value is minus 1. Here the difference value is going to be 0. So 0 minus minus 1 is going to be 1. And this max difference value is already 1. So no update is going to happen. Now before sliding, you update this, which is odd even parity. So odd even parity, what is the value? 3 minus 2, which is 1. This is already minus 1 lower value, so don't update it. Move to the right hand side, 9. Now at this point, you have even odd parity. Even odd parity, so on the left hand side, you need odd parity. So look at this odd value. It is infinity. That means there is no left side good option for you. Okay, so what you need to do? You need to just move to the right hand side, but before moving, you need to add this value, the information into the min value. So this is odd parity. So for odd parity, the value is 3 minus 3, 0. So this will be updated to 0 and it happened at index 7. So save it. Okay. Now you slide to the right hand side. Now here at 10, you have even parity. That means on the left, you need odd even parity. Okay, odd even parity. So look at odd even parity. This is minus 1. What is the value here? 4 minus 4, 0, right? But first we have to check the B's frequency. This odd even parity is happening at index 4. Check the B's frequency. Yes, 4 is greater than 2. So B has happened. And now you can calculate 4 minus 4 to be 0 minus. And then this minus 1 value, this is going to be 1. So already max difference is 1. So no update is going to happen. Before moving to the right hand side, update this information. This is odd parity. So for odd parity, you are getting 3 minus 3, 0. This value is already 0, so no update. Now you move to the right hand side. This is index 11. Here you have odd even parity, odd even parity. So on the left hand side you need even parity. Look at even parity, it is saying -2, that means it is valid and it is present at index 3. Go to index 3, compare the B frequency 2 with 4. 4 is larger, so B has occurred, yes. Now you can calculate 5 minus 4 is 1, minus for even you have -2, so -2, so that is going to be 3. So that means 3 is larger, so update the max diff value to 3. Okay, and now before moving to the right, update this information. So this is even odd parity, even odd parity. So look at even odd parity and the value here is 4 minus 3 1, but this is already a lower value -1, so no update is going to happen. Okay, now you move to index 12. Here you have odd parity. So on the left hand side you need even odd parity. Look at even odd parity, this is -1, that means there is an even odd parity which is valid. So the index is 2. Go to this index 2, look at the frequency, here it is 1, here it is 5, so 5 is greater than 1, so yes, B has occurred in the middle. Now you can calculate 5 minus 5 is 0, minus it was even odd parity, right? So it will be -1, so this is going to be 1, but already max diff is 3, so no update is going to happen and we are done. So once we are done, the max diff was actually tracking the maximum value of frequency of A minus frequency of B. Okay, and the parser which was going from index K to index N is actually your R value, and whatever this min index is giving is all your L value, which is following all the validity conditions, and we are doing it optimally in one time. So if you follow this dry run, then this entire approach is going to be order of n for each combination, and there are 20 combinations, so 20 times n is also order of n. That's what I will be assuming. But let's say that if you have m unique letters instead of just 5 letters, then in that case the number of combinations that you can form is m square, and so I can say that I will be taking n into m square time complexity. Now the space complexity is order of n in this case, but if m value can be very large, then I will write it as n plus m, but in this case it is just 5, so I have just ignored it. Okay, so I hope this entire approach is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the string and the k value, and I will be taking the size of the string and assigning the max diff value to integer minimum, that is -infinity. And then we will take 2 loops to try to create all possible combination of A, B, where I said it will have 20 combinations, right? And if A is B, then this is not a valid combination and I will be skipping it. Now I will be taking any combination AB and try to calculate the max diff value, or you can say the diff value, and we will try to maximize the diff value over all possible 20 combinations, and finally I will return the max diff value, right? That is what I will be doing. Now I will show you the steps. So if you look at the calculate difference, then in this case I take the string as the window size k, the A and B, which is the current combination. Now take the size of the entire string and assign the prefix sum A and the prefix sum B, which will be maintaining the count of A's and B's at all the indices. So if I can just show you that, we will move up and you can see the prefix sum A, prefix sum B is taken with the string, with the size of the string and A and B value, which is in the combination. So the first value is a dummy value, which will be 0, and we will be iterating only from index 1. That is what we will be interested in. So in the actual array, we will be iterating from 0 to n minus 1. But in the prefix sum array, it will always be I plus 1, which will be updated with 1 plus prefix sum at I, if the character matches with A. Okay, otherwise we will just copy the same value. This means that we are ignoring the rest of the values. Same goes for B as well. So I think you can easily calculate the prefix sum. Now once it is done, then we will be taking the min value of size 4, so as to maintain the 4 states: even, 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 odd, odd, even, and odd, odd. Okay, all the 4 states min value on the left hand side ranging from index 0 to n minus k plus 1 minus 1. Okay, and the min index, the corresponding value, if you have minus 1 value as the minimum value, where did it occur, at what index did it occur, that index has to be saved. This is the base case where we start, where you can say that we don't include anything on the left hand side, that means this part is empty, or you can say everything is included on the right hand side. Now we will be trying to iterate and try to maximize the difference value. So in this case I am taking the max diff for this particular combination, it will be minus infinity, and then iterate for all the r pointers pointing from k to n. K to n means in the actual array it will be going from k minus 1 to n minus 1, right? In the prefix sum it will be going from k to n. So these are the actual r pointers, right? So for each of the r pointer, that means for the endpoint, we will be trying to calculate at this rth location what is the parity in the prefix sum a and the prefix sum b. So check the parity a, parity b. You know that if for a it is even and for b it is, let's say, even, then on the left hand side you need an odd parity for a and you need an even parity for b. That means parity of b will not be changing, but for a it will be flipping. Okay, so that is how we are flipping, by using the XOR operator. 0 XOR 1 is 1 and 1 XOR 1 is 0. So that is the property we will be using. We are left shifting by one time so that parity of b gets appended to the right side. So parity of a, parity of b, where parity of a will be the first bit and the parity of b will be the 0th bit, right? So that is how we will be seeing. Now if min value at the parity is not equals to integer maximum, that means it is already saying that there is a valid index on the left hand side, then I will be checking its b's frequency. Okay, b's frequency. If the b's frequency here is x and here also you have x, then that means there is no b on the in the middle, that is from L to R, and so this is not valid. Otherwise if this is y, where y is greater than x, then it is valid, and so I will be trying to maximize the difference. This we have already seen in the dry run. After doing this, we will be sliding the start point to the right hand side, because if the r pointer is at index I and when I move it to I plus 1, then whatever was the L minus 1 value here, which is n minus k plus 1 minus 1, then if I move this r to the right hand side, the coverage will also increase by one time, right? So that coverage has to be added to the min value and the min index array, right? So that's what we will try to do. I will try to find the parity, odd, even, odd, what it is. Find the parity. Now this parity will not be flipped because we are not trying to find any target to the left. Okay, now see the parity and find out the difference between f of a and f of b at this point. Okay, save it in start diff, and if the start diff is minimizing that parity's min value, then that will be updated with the new start diff, and the parity will be updating the index as I had shown in the dry run. After doing it for all the r indices, we will be returning the max diff. So I hope this entire code is clear. You may have to go through this again to actually understand it in a better way, but this is a difficult type of sliding window algorithm. So I will advise you to have some patience and watch the video again if you have missed any of the points. I hope this was clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.